Okay. Excuse me. So what we'll do is we'll highlight the fact that what we're looking for is the constant term, and we're told that the constant term is 1280. So that means when we do our expansion, I think as you all told me when we were doing this, it means the x's need to go, and that's possible because we've got an x on top of a fraction and an x on the bottom of the fraction. And this was one of the mistakes people make to start with. When we do the expansion, the plus between those disappears and it becomes a multiply, doesn't it? So we could start by doing our expansion and go, well, it's 6, so it's 6, 0, and then it would be the first part of it, our a, so this is a plus b, would be x over a, and it's to the power of 6, because that's what the first one is. Now that's not going to be a constant term because I've got no way of dividing the x. So the next term would be 6, 1, and it would be x over a to the power of 5 times a squared over x to the power of 1, because the two numbers have to add up. Right? Excuse me. Now if I think about that, this would expand to x to the power of 5 over a to the power of 5 times a squared over x. Alright, because the 1 applies to both, the 5 applies to both. Now we've got multiplication of fractions. Now this would still end up with x's. I'd have 4 x's on the top. So I need some way of making sure the x's disappear. So that the only way to do that is to make sure I've got the same x on top as the bottom. So I can kind of make my assumption and go, right, the one I actually want is the 6, 3, pardon?
When they be in the half. So like half six.
Oh yeah, I get what you mean. Yes, so I know that I'm looking for x over a, and because the x's in each fraction are the same power, if they were different powers it would be a bit more complicated, but because the same power, I know I've just got to split this 6 into 2. That's why I knew it was the 3, so I've got 3 and 3. Right? So now my expansion would be 6, 3, then I've got x to the power of 3 over a to the power of 3, right, times a to the power of 6 over x to the power of 3. Alright, so at this point I know if I multiply those two things together I'm going to get rid of those x to the power of 3, aren't they? They go. There's suddenly my x is gone, I've got my constant term. So simplify again, well 6, 3 can be evaluated on your calculator in this case, which will give you 20. Then I've got to simplify a to the power of 6 divided by a to the power of 3 gives you a to the power of. So I've cancelled those out, so I multiply those things, so I've got a to the power of 6 over a to the power of 3, so it'd be a to the power of 3 left over because we subtract the powers. Alright, so the 6 minus the 3 gives me the 3. So that's my term, that's my constant term. Now what I need is what that equals, and I'm told that that equals 1280. Alright. So now it's just a case of finding a. So divide through by 20, I get a to the power of 3 equals 64. If I find the cube roots, I get a equals 4. Pardon?
Yeah.
Right, okay, should we have a look? Have you all done part A?
Like if you expand the bottom one, then are you
I'll talk to you about the expanding bit in a sec. Have we done A? Have you managed to do A?
Yeah.
Okay, so if we know that when we expand, we're going to have something in brackets and it's going to be 9 something, yeah? And in the first part of the term, we're going to have x to the power of something and then multiplied by 2 to the power of something else. And what do we know about the two powers? They add to make 9. And I want x to the power of 6, so that has to be 6. Therefore, this has to be 3. Then this can be either 9, 3 or 9, 6. Let's just make it 9, 3. Right? So then we've got, well, can you evaluate 9, 3 for me on your calculator?
84.
Pardon?
84.
84, okay. We have the x to the power of 6, but we have 2 to the power of 3, so that is actually times 8. And then we've got our times x to the power of 6. So what's 84 times 8?
678.
672. So there's my term. That's the term in x to the power of 6. That's it.
That's 6 marks. I'll take those 6 marks.
You'll take those 6 marks. Okay. Part B then. Now, the thing about part B is it could be very hard and long-winded and not, 2 marks is not enough to justify all that work. Alright? So you should always think, if I am working ridiculously hard for 2 marks, because normally it will tell you on the paper, won't it? There's probably something else you're being expected to do. Therefore, call a halt to it and go and move on to the next question and do the other stuff where you can do it in an appropriate way. Now the thing about part B, this is where they you could get to the answer but spend too long. So they're looking for one particular approach. Now, how would you think of doing 5x times x plus 2 to the power of 9? Would you expand the brackets? So I'm asking you, not telling you this is correct, is this 5x squared plus 10x to the power of 9? No. Good. Why not?
Because the 9 only applies to the brackets after you do the bracket first.
Good. So how would I apply the 5x bit? So that's wrong. When would I apply the 5x times? After. So I'd have to apply it to each term in the expansion, yeah?
Up to x.
What do you notice about the one that they made you work out?
It's the same. So now you just have to do 5x.
So I've got x to
But
the
it's
power of
x
6. What happens if I multiply x to the power of 6 by an x? Okay. So if I have 672 x to the power of 6, if I multiply that one by 5x, I end up with the x to the power of 7 I wanted, and I just have to do 5 times 672, which is? Pardon? 3,360. And there I have it. That's the answer. That's the x to the power of 7 in that one. Okay?
But it's still x plus 2 to the power of 9, but it's x to the power of 7 in B. So how are they the same?
So this bit is the same as this bit, yeah? So what we were just discussing is you apply the 5 to the power of the 5x after you've done the x plus 2 to the power of 9.
Mm-hmm.
Yeah? It has to be done to every individual term. You can't expand the brackets and then do the expansion.
Yeah.
Yeah? So that's what we're saying. So once we've done this expansion, we apply everything. Now we are looking for the x to the power of 7 term, right?
Mm-hmm.
So if we're looking for x to the power of 7, we need the term in x plus 2 to the power of 9 that when I multiply by 5x, I get x to the power of 7. And it just so happens that x to the power of 6 times by another x gives me the x to the power of 7 that I want. Yeah?
Alright.
Does that
That
make sense?
question was better than the first one.
Yeah. But could you see how, unless you made that jump and realisation, actually part B could be quite difficult. But if you understand that whole, well, I have to multiply afterwards, and then it's easy, but takes real understanding. And that's the difference. Alright? How do you feel about it?
You can't try to work it out by multiplying the stuff in the bracket, or multiplying the putting it to the power of 9, and then timing by 5. You can't.
Yeah, no, you can. So, for instance, I might think, well, I'll do that whole expansion and then multiply each term by 5x and see what I end up with.
Okay.
Yeah? But then why would I... Well, I guess if you did part A by doing the whole expansion and finding it, then you'd be able to just multiply them all by 5x and you'd get there eventually. You would just take a lot of time. And then by the end of the exam, if every question you took a lot of time over and did the long way, you'd run out of time, wouldn't you? And that's the thing with timed exams. That's how they differentiate. They kind of make it so that it is possible to do all the questions in a long way, but you run out of time. So I think, is it in Scandinavian countries where they give you an exam and they give you pretty much 5-6 hours to do it and you get as long as you need? So you can apply any technique you like to get to the right answer. Some people might be finished in an hour, you might be finished in 5 hours, but unfortunately you're not in that kind of situation. You've got to find the most effective, efficient way of doing it. And that's what they're looking for in, well, both parts A and B actually.
But Mr. Cox,
Yeah?
could you not just find x plus 2 to the power of 9, but find x7 from your previous one and then just times that by 5?
But what would I end up with? I'd end up with x to the power of 8. I'd end up with the wrong one.
Oh, I see.
Yeah. Now what they could be, there is a slight change. Now maybe they would not give you the one that you want in part A to use in part B, but they might be kind of, well, this is how you do it, now do it to a different one to find part B. But we've got here the hence find. That means use what you did, okay, in part A to find part B. If it says hence or otherwise, that means you don't really have to, there is another way of doing it that's perfectly acceptable. But this one is definitely hence. Use what we've just done in part A. If you're not using part A, you're doing something wrong or long-winded. Does that make sense? Okay. So, that's it. Those are my 2 past paper questions for you in a moment. You want to go back to your textbook and have practice on some other things wherever you found it most difficult today with these exam questions. Maybe you need to go back and find more on constant terms, maybe the harder exam style questions, or maybe you just need basics practice from right from the beginning. Find your point.